This is the third video in our solutions chapter, and today we're going to talk about when a solution is unsaturated, saturated, and supersaturated, what that means and how you can tell. I'm a big fan of hummingbirds, and I'm always making hummingbird food, especially in the summertime when they're out and about. And what I'll do is they like sugar water. So I will take my my saucepan, and I'll fill it with four um, I'm sorry, 4 or 5 cups of water. Can't remember. Yeah, 4 cups of water. And to that, I'll add a cup of sugar. Now, if I added half the sugar and I stirred, it would dissolve. It would go away. And I would be able to stir more sugar into that and it would still dissolve. That's the definition of an unsaturated solution. So in an unsaturated solution, the solvent contains less than the maximum amount. The solvent contains less than the maximum amount. Now, if you remember, room temperature is about 25 degrees Celsius. And if I wanted to put the maximum amount of solvent, of sugar, into my quart pan, I would want to do probably about 200 grams for every 0.1 liters I have. So if I have, that would be a saturated solution. That is when a solution has the exact maximum allowable amount of solvent. So saturated means your solvent has the maximum allowable solute amount. And I forgot to write solute down here. So solute. Well, how do you know? If you don't have a graph to look at, how do you know if you have a saturated or an unsaturated solution? And the answer is, if you slide this way a little bit, if you add more solute, so here we go, we're going to add more solute. If it dissolves, you were unsaturated. If it sinks and you can't get it to mix into the solution at all, it sinks to the bottom, then you know you had a saturated solution. You cannot hold anymore. What we have over here to the right is a solubility curve, and it shows us how much solute we can dissolve in a solvent, and this is in water specifically. So I told you guys most of the time our solvent would be water. So on the vertical axis, I have grams in 100 mils of water, and that's grams of solute. And on the horizontal axis, I have temperature. Now, the title says solubility of sodium chloride, sucrose, and potassium chloride. I don't know where the potassium chloride's at, but I do have salt. So this salt is NaCl. And interestingly enough, you can see with sodium chloride that it really doesn't matter if I raise the temperature. I have this 40 grams of salt per 100 mils of water. But sugar, on the other hand, has a really steep curve, a really nice parabolic curve here. And as I raise the temperature, so if I'm at 20, I can dissolve 200 grams of sugar into 100 mils of water. But if I'm over here at 80, the number goes up to 350. Well, remember we talked about our solution prep factors, and we said that if I raise the temperature, I am raising the frequency with which the molecules are hitting. I am also increasing the force at which they're hitting, and that's going to cause a breaking apart of the solute. It also brings fresh solvent into contact with the solute. So this is called the saturation line. the line of saturation. And this tells me that at 80 degrees Celsius, I can, for a saturated solution, use 350 grams of sugar. If I had a 20 degrees Celsius solvent, a saturated solution is going to be 200 grams per 100 milliliters. So this is going to show me the maximum allowable amount. Well, what's this supersaturated? This happens when we create a saturated solution and then it cools slowly. So the requirements here are, first you have to have a saturated solution. Saturated solution. And then second, you have to let it cool slowly. So let's say I created this saturated solution of sugar water and I raised it to 80 degrees and I dissolved let's say I only had 100 mils, I dissolved 350 grams into that 100 mils. As it cools, so we're coming out here, and as we're cooling, this solution, as it drops down to 40, should only be able to hold about 240 grams, but it actually has 350. This solution at this point would be a supersaturated solution. The reason this happens is we have suspended the solute into the solvent, and we have separation between the water molecules and everything's very kind of static. But if you come in and if you're let's say you're making fudge, this is the basis for making fudge. Your fudge is sitting on your counter, you make a saturated solution, you throw some chocolate and some other things in there, but it's mostly sugar and water, and you let it cool. The goal is to let that cool all the way down to room temperature, and then it really won't change, and you get this nice creamy fudge. But often what happens when we make fudge is we're cooling. We come to this point and somebody bumps the table. That bump causes a rapid deposition of all of the sugar. It just goes whoop, and it drops, and you get all of these grainy little crystals of sugar. So what can happen with a supersaturated solution is movement, or if something falls in, if a speck of dust falls into the pan, or a loose piece of sugar, or the addition of some matter, you get what we call rapid deposition, where all of the solute, so, well, actually not all, so this much solute, all of the excess solute drops out of solution at once, drops out of solution at once. And we are going to do a demo in class where we're going to do some supersaturated solutions, and when I uncork them or I move them, they become completely solid in an instant. We can use these solubility curves, though, to predict what we would need to make a saturated solution. So let's look at a couple of sample problems. Problem 1 says, how much sugar can 100 mils of water hold at 20 degrees Celsius? Well, we kind of already looked at this. So at 20 degrees Celsius, if I come up and I come to the sugar line and I come over to the left to see grams of solute, in this case sugar, in 100 mils of water, I'm going to see that I could hold 200 grams of sugar. The next question says, will 350 grams of sugar dissolve in 100 mils of water at 70 degrees Celsius? So again, we're looking at sugar, and I'm going to come to the 70 degrees Celsius line. I'm going to come up here, and then I'm going to draw a line over to the left. And what I see is that at 70 degrees Celsius, I can only dissolve about 320 grams. So the answer is no, only 320 grams. So what are our takeaways? We have 3 types of solutions: unsaturated, saturated, and supersaturated. Unsaturated has less solute than is the maximum that it can be held. Supersaturated, saturated has just the maximum amount of allowable solute. And if we continue to add solute, it'll just drop out to the bottom. Supersaturated, we have to have a saturated solution that cools. And it might be able to cool down to room temperature and become stable in the case of fudge. But in this case, we were talking about if we had movement or we drop something in the pan, you'll get this rapid deposition of solute out of the solution. We can also use these solubility curves then to answer questions about forming solutions. All right, that's it for saturated, unsaturated, supersaturated. Thanks for watching.